There are many obstacles that can block the path to a successful software project. When you come across one, it helps to think like a seasoned hiker and follow the trail marked by blue blazes around the problem so that you can get back on course and keep moving forward. Welcome to Blue Blazes Podcast. I'm your host for the journey, Jay Tower, and I'm a partner and principal consultant at Trailhead Technology Partners. In this series, we talk with industry experts who share their best tips for avoiding the pitfalls on the path to successful software projects. My guest on this episode of Blue Blazes is John Waters, a seasoned technology leader, software architect, and my fellow partner at Trailhead. With John's decades of experience in software architecture and a career spanning the US and Sweden, he's delivered many innovative solutions for industries including transportation, finance, and healthcare. In this episode, John and I dive into what's happening in the fast-evolving world of AI for .NET developers. Drawing from his extensive industry experience, John helps to highlight the most impactful updates for you to keep an eye on in this space. I hope you enjoy the conversation as much as I did. All right, well, welcome back to the podcast, John.
Thanks, Jay. Good to be on again.
Well, it's great to have you. I was looking at the podcast history, and it looks like it's been about 8 months since we talked last time, and we were talking about .NET 9 at the time. But now we're talking about something else that evolves very quickly, even maybe faster than .NET versions, which is AI in .NET or AI for .NET developers. So as you think about the landscape of the many tools that are available out there that are evolving really quickly, what are the ones that kind of catch your attention as the most interesting things, and maybe both things that you can help to write code with, and maybe also things that you can help to implement AI features in your own code with?
Yeah, AI is such a huge kind of topic, and every piece of it is evolving exponentially. So there's a whole plethora of kind of chat GPT like offerings for you to just be generally productive. And then there's kind of more specific tools, maybe for a developer that will integrate into one of your IDEs and maybe help you write code. And then there's frameworks, SDKs and foundational classes that make the job of writing AI code, let you work at a higher abstraction level or be more productive. So it's a kind of a whole array of tools. Things like GitHub Copilot, come to mind as plugins to your IDE that do help a lot with your kind of development task. But you can also kind of use some of these language models and tools just kind of on the side in the browser to help with your development tasks, which is kind of how a lot of people, I think, start out until they figure out how to actually plug in, these models into your development work stream and then have them start actually doing work for you.
Jay here. Just a quick break in the conversation to share how Trailhead can help you tackle your toughest business challenges. When you're navigating uncharted technology terrain, Trailhead creates custom software solutions that put you back on the path to success. Ready for the next step? Get started with an expert consultation at trailheadtechnology.com/offer. That's trailheadtechnology.com/offer. Now back to the conversation. Yeah, and you mentioned GitHub Copilot, which is obviously a popular option in that space. And they just announced recently that there's a third mode that you can run GitHub Copilot in. So before it had the completions, that was kind of the first thing they had, and then the chat interface, which, like you said, is sort of feels like Chat GPT or something, but it can also edit your code. And they just recently added agent mode. So how do you see that new agent mode changing the way people use GitHub Copilot going forward?
I've tried it a bit in some projects where I initially started with just kind of, hey, here's some code, how could I optimize this, or how can I write this entity framework core statement, that kind of thing. When you switch it to agent mode, it can start to edit your whole workspace. So you can do things like refactoring things across a bunch of different files. It can call out to tools We can talk a bit about MCP later on, but it can kind of call a bunch of tools and make some pretty big changes to your code. And then you can review those changes and comment on them and accept them, or accept them all, accept some of them. But it's at that point, it's writing code and changing your source code for you.
I think I heard Microsoft describe that as now GitHub Copilot is one of the developers on your team.
It's very interesting how they view it, because I was just looking at a whole session about kind of the coding agent they also have, and they were contrasting the coding agent, which runs in the cloud, to agentic mode in your IDE. And in both cases, it's a team member.
Mm-hmm.
In the IDE, you're kind of micromanaging this team member. Um, every single little change is something you request and approve of. In the coding agent, it's more like you give someone a task to perform in an issue on your task board, and it does a bunch of work, and then does a pull request, and then you can comment on that, and it will iterate on that pull request and so on. But it's even more independent of you. But in both cases, I think Microsoft views that agent as a team member, and more specifically, it's a team member that reports to you. So the changes made to the code and the check-ins appear to be from you. So you're kind of responsible for the work of this thing. And so you really, can't just accept that code and check it in without reviewing it. And I think many times you can see code. I've seen lots of code. My coworkers have seen code in clients' projects where someone who doesn't know much about a topic has some AI write the code. Just it compiles. Let's check it in, and you see that code doesn't have the same style. It's almost the same way as when you read a blog that an AI has written. You can tell immediately that it was not a person
Right.
if you don't put your own spin on it. And if you don't refactor and look at the code that's generated and make it your own and kind of work on it, it looks like a foreign artifact in your code base.
Yeah.
So
Yeah.
you're kind of responsible for this agent, whether it's agentic mode locally or kind of doing a lot of work, but it's still ultimately the developer right now that's kind of orchestrating
Right.
and reviewing it.
Yeah. Important to note that the integration point, even for the cloud-based agent, there is a pull request, not a push into a branch of code.
And there are a lot of kind of guardrails around this right now. Like it will do its work in a specific branch of a specific, base branch, and it won't, has specific repositories it has access to. It can't be pushing stuff without review. And there's a lot of things like trying to make sure that whatever this thing creates, it's passes through the eyes of some kind of human. Even if you have a workflow that says you need 2 approvers for a pull request, you don't count. The person that told the AI to do something is not one of those approvers. So you have
Oh,
someone
interesting.
else that's kind of not part of this
Mm-hmm.
little scheme.
Yeah, that's probably the right way to do it. Just like testing your own code is a little problematic. Okay, so that's kind of all on that like generating code side of AI, but there's also this other side, which is as developers, we want to add AI features to the software that we're making. And there's all these frameworks and tools and SDKs and APIs and stuff out there for that. What ones are drawing your attention right now to keep an eye on that side for .NET devs?
So there's a couple of kind of main areas. From the beginning, there was just, I think, a lot of an ocean of different things that weren't quite connected and didn't really have a common types or like a common thread. And there was this thing called Semantic Kernel that had all kinds of kind of things in it for working with AI. And then along came something called Microsoft.Extensions.AI, which was kind of an attempt to take a lot of all these different things and make them more like foundational types. So things like a chat client that is a common abstraction, um, things like an I embedding generator or an embedding a chat message, kind of abstraction of things that you do in AI. They all now kind of are in this uh, Microsoft Extensions.AI, and you can almost think of that as the .NET framework for AI development. It's kind of all of your base classes, and then Semantic Kernel is more of a higher level abstraction where you can build things on top of that foundation. And it has now been rewritten to internally use all of those foundational types instead of its own types, but actually both right now exist in parallel. But the
Mm-hmm.
idea is that the semantic kernel will kind of be on top of the AI extensions, and it has more abstractions of things like agents and processes and workflows, and kind of lets you build things. Maybe you think of it more like NuGet packages on top of your base .NET framework. They, they
Mm-hmm.
they make you more productive. So you've got those kind of two levels of things. And then there's a lot of specific technologies that you would use in a project, for instance, vector databases, vector stores, embeddings, chats, language models. We can talk more about each of those things, but those are kind of big clumps of things that a lot of AI is built upon as building blocks. Or if you're in kind of the more classic machine learning space, trying to use data to find kind of patterns or classify things, and there's an ML.NET set of classes that are specifically tailored towards more like data science. So you say like
Got it.
ML.NET, data science, Microsoft Extensions AI, foundational classes for all kinds of AI, semantic kernel, higher level abstractions on top of that foundation for
Got
more
it.
chat based work.
So you mentioned the Microsoft extensions, which has been a really powerful way to sort of systematize or make generic based things for all the AI, different AI things that you can do. And I saw some news recently, you might have seen too, that there's now a Microsoft extensions vector data that's kind of a sister
Hmm.
package that goes with that. What
Yeah.
what do you know about that so far?
So vector is kind of interesting. We kind of have an understanding of vector, maybe kind of from physics or something, like a pointer in some dimension, but it could be
Mm-hmm.
multidimensional. And a tensor is more like a generalization, a multidimensional vector, or think of it as a matrix or a multidimensional matrix. But it's even more than so. Um, when you start working with large amounts of data, you can't necessarily fit it all into memory, or it could be sparse. You could have big gaps in it. You might want to work with kind of a little block of data out of some huge underlying data space that you have on disk. And so vector data is a way to kind of create an abstraction similarly to the way span of T has created kind of a good abstraction over things like lists and collections and memory and all kinds of things that are contiguous pieces of memory. The vector of T is really kind of an abstraction of multidimensional shaped data, and it's ubiquitous. It's something you will find in vector databases. It's something you will find in ML.NET. So it's another one of those great abstractions that will help you. And an even more important thing is there are so many permutations of hardware that might be the underpinning of your vector. You might be using GPUs or CPUs. There's a whole bunch of different kinds of GPUs. There's all kinds of hardware. There's figuring out how to even sum data in a matrix. There might be tons of optimizations about how you would do that depending on how many cores you have or
Mm-hmm.
what kind of instructions that you have. And you could write tons of code to do that optimally, but that's kind of what they've done in the vector data um, classes is you work at a very high level and say sum this tensor for me, and it figures out, given the hardware you have, the best way to do that, or even just given the shape of the data. Maybe if it's a small thing, it does this. If it's a large thing, it does something else.
Mm-hmm.
So allow you to work with data across a variety of different kinds of hardware.
Yeah, it sounds super useful to have that abstraction,
Yeah.
since most of us business developers aren't thinking about things like architecture of our processors and how many cores we have in them, all that stuff very often, other than maybe when you're buying a new computer. So you mentioned MCP. That's another thing that kind of exploded on the scene in the last 6 to 9 months here. It's the Model Context Protocol. I kind of think of this as an analogy similar to how REST came along and created. I think you could make the argument it's a little bit more of a fuzzy protocol, but a protocol nonetheless for people who are trying to get data from APIs on the internet. Is that kind of how you think about MCP for AIs, or do you think about it as with a different analogy that's more useful?
If you go back even further into things like WCF, and back in that time, you had things like discovery, and you could connect to an endpoint to find what kind of services were there and what their data types were and everything else, so that you could even generate code that could use those endpoints. It's almost more like that, because MCP, if you have an MCP server, take an example that we've done something recently. Say you have a private data store of documents or something that's not on the internet, and maybe you vectorize that and put it in a vector database and made it searchable. You want your chat application to be able to use that data in the data store, and you might want to expose different methods. For instance, give me a list of documents, or find documents with a title that matches some words that you're interested in, or find documents whose content talks about the things that you're interested in. So you could provide a whole array of those different functions that could be useful to work with your private data. And then you can expose those as functions. You annotate them with annotations that say, this is a tool basically, and you can specify some information about what the data types are as well to make life easier for who is consuming this. And then once you've annotated what these tools are, you kind of publish them in a way that another tool can discover them. Um, and then that tool, being say a language model, will look at that list of tools, and it will figure out, well, do any of these make sense to call to accomplish my task? And maybe it uses a whole array of tools. Some of them are your private document store, and some of them are some other tools that someone else wrote. There's actually thousands or hundreds of thousands of MCP servers out there now that do everything from give access to your Figma drawings to generating all kinds of artifacts. But with MCP, it's kind of a standard for how all of those tools can describe themselves and how you interact with them. And you can do that in multiple ways. It can be as simple as running a console application that uses standard I/O. So you're basically using standard input output to pass data in and get it back again. Or you can do server-side events where the tool is streaming back responses. Or you can do streaming HTTP, which is bidirectional. And you can have an MCP server that tracks session state across a bunch of MCP clients and like uses the same connection and a session ID to keep them apart and keeps the context. So there's all kinds of levels of MCP connectivity, and the most recent additions also now allow you to do authentication. So you can have like an OAuth endpoint in your MCP server, so that you'll have restriction to who can call the MCP tool. So it's become a whole kind of way to package custom functionality, make it discoverable, make it secure, and what's been cool is the whole ecosystem has embraced MCP. It started out, I think, from Anthropic, but now Visual Studio Code, Visual Studio can use MCP servers. You can use MCP servers in your own code. Every which tool is like getting you the ability to like add an MCP server and just choose from a list of them. You can put them in containers and publish them to Docker and get them from there. So there's now just an endless amount of MCP tools around, which is enabling our AI solutions to do really useful things.
Mm-hmm. Yeah. So you mentioned a minute ago about using local models as opposed to, on the cloud models. Someone's thinking about writing a feature with AI and they know they need a model of some kind, a large language model, most likely. How do you think about whether they should, what are the trade-offs and whether they should use a local model versus one of the larger cloud-based models?
There's a few things. There's privacy, there's cost, there's performance, capability. Um, in general, you want to use really the smallest model that can get the job done
Hmm.
because the bigger models need more resources to run. At some point, they get to where you can't run them locally unless you have some ridiculous machine. So
Hmm.
those really large models, you really only can consume when they're running in some huge data center. But we've got a project running right now where we just spin up two containers. One has Olama, which can host a bunch of different models. So we'll host like a small model in Olama, and then it also hosts a embedding generator for generating vectors for text, also as a small local model that is specialized in vectorizing text. And then you can have maybe a container with a vector store or something. And so you can build a whole local set of resources that it's private. The data stays in your wherever you're deploying your stuff. It's pretty fast because it runs kind of locally, and it's not doing more than it. Um, you're not giving it tasks that require a lot of thinking, and it's pretty much free. I mean, you have to pay for where it's hosted, but there's no you're not paying for tokens.
Hmm.
So I think if you can get away with that, then that would be your default approach. Would be use a local model that does your work and just kind of build it into your deployment.
You mentioned speed as a reason potentially. Does that also include like apps that might be connected and disconnected from the internet or connected at different speeds at times?
Yeah, yeah. Obviously, your local model can work in offline mode,
Right.
and I think there's more and more of those available now, and there's all kinds of ways to host them. Like I think you've got Olama, you can load a bunch of models. You've got used LM Studio. I think Microsoft just came out with what's it called, Foundry Local or Local Foundry,
Hmm.
but they all are kind of a container that can host models for you, and then those local models can use things like GPUs if you have them.
Yeah.
I think that
So,
there's a trend towards kind of more and
um,
more local, specialized, small models that are good enough for the task at hand.
mhm.
And maybe at some point, you'll get models running on your iPhone as well.
Okay. So we talk a little bit about pragmatic AI here at Trailhead, and I'm sure we all probably define that a little differently. But one of the ways I think about that is, a lot of organizations right now they have decided they want to do AI, and they're in search of a problem to match that solution. So, just kind of talking about how we do our pragmatic AI here at Trailhead, how do we kind of think about that for like what's a good potential fit for AI?
Yeah, many times we've already built a solution that is working, is in production, and our customers have some kind of pressure from their owners to say like, how are you using AI in this product? And they're like, we don't know how we're going to use AI. Trailhead, how should we use AI in this project?
Mm-hmm.
And it kind of boils down to, I think, just jumping in and trying things like small proof of concepts and pieces of the solution. It's not just reimagining everything as AI, but for instance, we have a customer that has a search for supplements, which have names, and they'll type the name, and if they don't type it exactly right, then it doesn't match anything. So there was a requirement. Well, can we do a fuzzy search? That kind of gets what you're looking for.
Mm-hmm.
And we thought, well, SQL Server kind of like fuzzy search, full text search is that the way to go? And then we thought, well, what about trying like a vector database? Like it understands the semantic meaning of things. It's not super concerned about spelling. It
Mm-hmm.
gets what you're looking for. If I ask for a vitamin C and I spell it differently than it's spelled in the database, it will understand what you're talking about. So we just took that little search drop down and built an ABI that instead uses a vector database, and then we built kind of a little pipeline that takes the the table that they're searching in and just creates embeddings and puts in the vector database, and then swapped out that API to use a vector search. And we got really good results out of that. So now that system is using AI for this little piece of functionality. And I think that's the way to go, is like looking at features in your product that could benefit.
Mm.
Say another one we have is um, customers that have uh, warranties for things they purchased, and then they want to know if a problem with what they bought, it would be covered by the warranty.
Mm.
And so now you can build a chat interface where an AI and large language model can ingest the customer's, um, warranty document and read it, and then look at the claim and say, well, yeah, this is not covered, or yeah, this is covered, and so have
Mm.
kind of a little really useful thing where you're using this private data that is the warranty document to help a customer and maybe offload your call center.
Mm.
It's a little useful pieces where you plug into a functional application and just make it better.
Yeah. What I like about all of those is that like they're a perfect fit for what vectorization, semantic search, AI, large language models do, but none of them is like reinventing the application. They're just making it significantly better at what it already was doing.
Another example there is you could have a claims intake process where the user has to submit photos of damage to something, and then they
Mm.
have to go in and describe the damage with a bunch of drop downs and stuff. Well, why not just you upload the document, ask the AI to analyze what it sees there, and fill out the form, and for you.
Yeah,
That
very
makes the
useful.
customer happier.
Mm-hmm. Well, we've talked about a bunch of different things. We talked about Copilot and extensions AI and semantic kernel. We didn't really. We talked about local models. We didn't talk a ton about ML.NET. So, like, what else is there as we kind of wrap up the conversation here? What else is there that a .NET developer should be aware of that we maybe didn't have a chance to talk about yet?
I think one thing that took me by surprise was Aspire.
Mm.
They have worked GitHub Copilot into Aspire in a really useful way.
Mm.
So Aspire is kind of like, if you think of Docker to compose as code, like you're writing C# that describes all of your different uh, components in your project and how they depend on each other. But it also instruments them with gathering open telemetry, so it can capture your logs, your structured traces, a bunch of information. And so when you launch this, you get a dashboard that shows all of your components running, like your API and your web and your Redis cache and your database and everything else. And then it starts gathering all its telemetry. And then you have an error. Maybe it's a database error or a network error or something in one of these logs. So GitHub Copilot is now integrated into that dashboard. And you can just ask it, like, what's going on with this error here? And it can look at all of that telemetry from all of these different components and give you an explanation of what's happening and what to do about it. And it's really helpful for
Mm.
diagnosing um, problems in distributed systems.
Mm.
I can't wait for the next level where that GitHub also can look at your source code, because the GitHub Copilot in Visual Studio knows all about your workspace and all of your code. And then the
Mm-hmm.
one in Aspire knows all about your running code. If the two
Mm.
could get together and say, hey, here's what you need to do in your source code to fix this, it would be pretty cool. I'm sure that will come soon.
That would be really cool. Yeah, another very pragmatic use of AI there, because distributed systems are so hard to debug when there's different things happening in different systems, but they might be related to each other, and to try and tie that all together, even just to go find everything and read it and understand that it is related, is tough.
The,
So it's
the
great.
cool thing about it too is that usually these systems have just a huge amount of log data. And,
Mm-hmm.
and so you don't even have to find the right part of the error. Like you can just say, here's all this data, and it will figure out what's relevant in there.
Yeah.
So you don't even have to kind of put any effort into it. And it benefits not just from having all of the logs from all of the components. It also is a LLM that knows all kinds of things about architecture, and it knows all kinds of
Mm.
things about Redis and SQL databases and different exceptions. So it can look at the text and it can look at its general knowledge of systems, and it can give you some really good advice. I can tell
Mm-hmm.
you, for instance, that when you get a not found, when you're creating a blob container, there's like a creative not exists call that you make to create the container if it doesn't exist. And it's quite expected that, in most cases it does exist and it's not an error, but it has an error code in the response. And so the AI will just say, yeah, there's no need to worry about this. It's expected.
Mm-hmm. That's pretty cool. Well, a lot going on as usual for this last year or so here in the AI space for .NET developers. So thanks for helping us get a little bit of an overview of what to keep an eye on, John. Really appreciate your time and expertise.
Thanks, Jay. See you next time.
That's the end of this Blue Blazes podcast. If you're interested in hearing more conversations like this one with industry experts focused on how to make software projects more predictably successful, make sure to subscribe. Trailhead can be found online at trailheadtechnology.com, on Twitter, LinkedIn, and Facebook. Until next time, thanks for listening.